introduction.
Short
Ladies,
one.
yeah, ladies and gentlemen, welcome again to another talk. So this afternoon we have professional geologist James Bachat. He's actually CEO of Borneo Geoscience, that's based in Kuching. I just talked to him, based in Kuching, and he actually graduated from UKM, BSc honors in 1999, MSc in 2005. UKM yeah, hardcore UKM graduate.
Yeah, you are my ex lecturer, so
I spent half my life in the same university.
yeah.
Okay, yeah, he has been involved in many projects, engineering projects. So I just quote a few of some hydroelectric dams, and then of course the famous Borneo Highway. I think that one should be very interesting. Borneo Highway, yeah, and then some repair works, and he has published quite a number of papers lah. So I think we look forward to his talk. Lots of case studies, I guess. Yeah. Title is Geological and Geotechnical Problems in Construction in Sarawak. Okay, the floor is yours, James.
Okay, thank you, Mr. Tan. Actually, I think this is my first time giving this opportunity to giving talk to the GSM. Okay, I would like before I start, I would like to thank you for the GSM, especially Mr. Tan punya unit, and also because this also collaboration with the IGM and also with the Jabatan Geologi UM, I guess. Okay, my presentation today is about the geological, and geotechnical problem in construction in Sarawak, which is based on my experience before. I will focus on the geological formation that involve a lot of in the construction, especially in the newly developed area or township. I totally focus on the sum of the geological formation, so that because different geological formation give a different geological characteristic that can give you a different solution in terms of the engineering lah. Okay, how to next? Okay, how to remove this top part? Okay. For the table of content, I will explain a bit, just a bit about the geological evolution of Sarawak, which is actually the origin of geology of Sarawak, how the geological form, and then in comparison to the Semenanjung side lah, and then after that I talk about geology of Sarawak, certain selected few geology formation, which is involve a lot of based on my experience lah. So after that, I will explain on a few case studies, especially on the unfavorable geological conditions of some of the geological formation and the construction risk. So this is something that we can share here, especially those that in the developed area and also the newly developed area. After that is conclusion. Okay, about the background. Okay, about the background. I'm not going to talk about the tectonic setting whatsoever, but I want rather to explain on the uh, geology origin of Sarawak. Okay, actually, if you see this on the left side graph here, okay, this is the geology of Sarawak actually is formed by the collision between the Paleo-Pacific, which is on the left side in West Borneo basement, where actually you can see a Kuching site is here actually. Okay, in the other side is still on the deep sea. After that collision, you can see at the Miocene time there's expand a bit because of the uplift of the West Borneo basement. And then this Lupa line here, so Kuching site is already here. Okay, and This part actually is a newly because of the erosion of this site. Later I will explain a bit more details here why it is formed. And then from this model, actually we can assume that Kuching zone, actually there's three tectonostratigraphic zone here. We have this Kuching zone, which is this part. Boundary is at the Lupa line here, and also the Cebu zone, which is a deep marine Rajang group, which is here. Okay, which is here, and also Miri zone, which is newly from the erosion of the Cebu zone. So this is the origin of Sarawak. But actually, for the Semenanjung side, actually Kuching, this is a part of the Senal land, which is connected to the Peninsula Malaysia. Almost similar geology with the Peninsula Kuching side, but because of this subduction, we may have some what they call this subduction or accretion phase here. Okay, later I explain how it affect geology in Sarawak. Okay, and then this is a geology map from JMG, third edition 2013. And then we have three zones here. Okay, the Kuching zone is, like I mentioned earlier, is a tertiary basin sediments and igneous rock. So this part, at the most western part. And the Cebu zone is a deep marine sediment, which is mostly is a Balaga formation. During the how is deep during the subduction zone, this part is still a sea. It's a deep sea. That's why this is how the geological form here lah. So the green one is a layar member. This one a carpet member at this side. So a bit affected by some not very weak metamorphism here. We have phyllite. Here is a Balaga formation and also Pelagus or Metah member. Murup area is Metah. So Cebu zone mainly is Balaga formation. And then the Miri zone is a younger marine terrestrial sediments, which is the affected by the erosion from the Cebu zone also, and also some of the marine young marine. So from this, actually, what we can say here, geology here is younger toward northeast. So later I show which one is the youngest geology formation here. So the youngest is along this coastal area, especially the Liang formation here. I will share a bit on our experience before with the Liang formation later. Okay, if you look at this, how to remove this? Okay, for this presentation, I just focus on the one that I highlighted here. From the oldest rock formation, Tuang formation, and Plau formation at the Kuching area, Layar member, Kayan sandstone, and until the young geology formation is a Liang formation. So this is the focus area in this my presentation today lah. So because of the major development or the major construction happened in this geological formation. Okay, we start with the Kuching site. Kuching actually is mostly underlined with the Tuang formation. This is a brown color here, Tuang formation. Padawan formation scattered all over place at this Petrajaya and also Batu Kawah area. Kayan sandstone mainly on the Santubong and also the Padawan area, the highland area. And also we can see the deep pit area surrounding Kuching, especially on the Matang side. So actually Tuang formation here, what we can, the geological here, a lot of the sheared material, bracketed material, for gauge. I will share a bit some of the evidence that we found from our previous project. Okay, tightly folded and also strongly jointed, strongly joined with abundant quartz and calcite bands. Okay, this is the Geological formation, tuang formation, which is consists of phyllite during the drilling, meteoritic quartz micasis, quartz tremolite epidosis, also silicified stuff. And then because actually it shows very strong metamorphism because we found a lot of microtonalite on the side, microgranulite. So all this material, most of the material that we found is a folded, sheared, silicon-sided surface. So a lot of silicon-sided surface, and also breccia everywhere. All this material. Oh, but this material could be part of the accretionary prism affected by that subduction process, or maybe it's related to the igneous extrusion. Why is this become breccia a lot everywhere? If you measure the bedding, interbedded, everything, but that is a very uh, difficult to determine because it's already sheared. Maybe shows a very strong compression or because of this silicon-sided uh, from the fall activity. Okay. So for the confirmation, I just want to share about the fall gauge here. Actually, during our drilling, one of the foundation building, we have found a 3.8-meter colossus, and also because we want to know what's happening there, we test the packet test, and it shows very high permeability. No, sorry, impermeable. So the water cannot pass through. And then when we do wash boring, the color of the water is whitish, and also the angular fragment, which is put in the plastic bag. And then from this characteristic, we define that that is a fall gauge because of the white color of water is actually from the clay mineral that inside the fall gauge. Fall gauge actually is a fall that contain breccia, where is the fine material is a lot more than the class. So this is how indicate. So this information is very important, especially for the foundation of big building. Okay, this is what happened below the Kuching town. There's a lot of tuang formation. And also another part is a Padawan formation. It's partly Padawan formation is a thick sequence of shell, mudstone, and sandstone with bed of conglomerate, chat, and also limestone. Here they mention about limestone. Later I have a few cases with the limestone and acidic to intermediate lava and turf. So this Padawan formation mostly at the Padawan area with the hilly area and partly at the Kuching town. But the Kuching town, what is the mainly is below the ground is limestone, the prison of limestone. Later I share one cases. Okay, for the mudstone, which is mudstone or shell, is a argillaceous material, which is a very highly easily erode away, severe gully erosion. So in this case, just a slope protection and also may can lead to the failure. So this information have to take into consideration in the construction of the road, cut slope or whatever. Okay, in the Padawan formation, another unfavorable geological condition is a cavity in the limestone. Actually, this Padawan formation is not actually it's a large body of limestone. It's not lenses. It's a very large body. This is from the previous drilling. Okay, they have a cavity. There's a lot of cavity down there, especially at the Putrajaya area near Masja, near State Archive there. So some cavity they have infill cavity with clay, sand, and also rock fragment. So any excavation or any foundation project in this material, any disturbance down there, actually they have to do some extra work lah. Especially if they want to grouting this cavity, they need to pump out this sand or clay whatever infill inside the cavity. And also it might lead to the water loss, where water loss can happen, which can lead to the ground sediment also. So there's a lot of problem. This is Padawan Formation. It's a limestone. Okay, but for the other rock type, maybe not a really much problem lah, in terms of the foundation. Okay, if you see on the right side, there's some piling problem in the limestone areas. This is just the photo is just indicative only. So imagine if you do some piling works on the limestone area, and then if you do the pile group, and then you notice that the pile is not same length when you try to penetrate into the ground. So maybe this is something that very, the very high geotechnical constraint here. So the understanding of this limestone information underground, because you cannot see, so it's very important here lah, in the foundation, especially in the Kuching town. Okay. After that, Kayan sandstone. Kayan sandstone, this occupied the Santubong area, Santubong, Padawan, especially on the hilly area. So actually, it's mainly consists of the sandstone, massive sandstone, medium to thickly bedded sandstone, pebbly sandstone, conglomerate, or any intercalated with sequence of thin bedded fine grained sandstone with regularly interbedded with siltstone shell and mudstone. In some part of the area, we can find some very thin layer of shell here. So the bedding shows that plant is gently to moderately dipping toward northwest, not west to west, especially on the Santubong side. You can see there's a lot of boulder there because of the toppling issue here. From this model, actually this is from Santubong side, we found a lot of the pressurized tripling, which lead to a lot of boulder along the river. So this is another thing that geotechnical constraint in this formation. Okay. And then the deep pit at the Kuching town, as you can see here, based on the lump checking 1998, shows that they call this a paludal deposits, which is mostly at the Matang area there. Actually, a solution unit made up of a mainly pit. And then you can see pit, it can up to 6 meter depth and also reach the residual soil up to 9 meter. So this is something that have to take into consideration. Pit, because pit is decomposed plant, so the temporary work during the construction, treatment, whether you R&R, remove and replace, will be very costly. There's a lot of things need to consider in the construction along the pit. So from this map, actually, pit mostly occupied all the major town area like Cebu as well, Muka area, and also Kolabaram there. So there's a lot of pit in Sarawak. So have to do a lot of the assessment on this pit, especially the thickness, moisture content, and all this information. Okay, this is the conclusion from the coaching side. What I can say about geological collision, we have, like I said, sheared braided materials, considered surface, polygons. So the concern risk on the foundation, this part is a foundation, so longer, it could be maybe longer socket length for pile in the sheet material, possible for water leakage, draughting, for fault gauze, and there's a lot of the issue here. But actually, tomb formation in Sarawak may not expose lah, because I don't think this, because it's a very low hilly area, so unlikely to be exposed. If there is, maybe there's a sliding along the plane, sheet plane and all this. Okay, Padawan Formation, the presence of mudstone and also limestone, where is a lot of the risk here. You need, especially in the limestone underground, you need extension foundation work like permanent casing, grouting. You might need end up with the concrete loss and water leakage. Okay, and then to determine whether all your foundation lie on the very good ground, you need a percussion drilling during the construction, and then also pipe socket length will be longer in the mudstone area. So that is the foundation for the slope. Sliding along bending plan because this we found there's some interbedded and slope protection to control erosion. So for Kayan sandstone is mainly on the rockfall and also colluvium at the bottom of the hill, sandy gravelly material from actually this is from pebbly sandstone and also conglomerate. Foundation and boulders, this is on construction risk in the Kayan sandstone. On the slope also is fallen boulders like toppling, just mentioned earlier, water seepage, wet ground because of the high impermeability of the pebbly sandstone and also conglomerate. Padawan area, the ground is always wet because of this character. So slope deterioration, colluvium, subsoil. I think this is wrong. So soil drain here, and then the debris flow along the major river. So the deep pit, there's a lot of the ground treatment, remove and replace method, especially temporary work, and whether you want to remove completely removable, that is another risk. Okay, we go to Cebu. Cebu in the town area. Okay, from this pit map, we have a very deep pit up to 10 meters. So it's a very deep pit. You may need a ground treatment on the pit. And as you can see from this graph, actually the pit is thicker toward the inland because of the water stagnant, and then it's no river, no stream. So the plant remains stuck there. River is already washed away, so that's why it's not much of the this pit. But actually, near closer to the sea on the other Cebu side is can up to 4 meters, still quite deep. This one, and also like I mentioned earlier, Balaga Formation cover most of the Cebu zone area. So with this, later I share on the thick shell of a layer member and also phyllite of a carpet member. Okay, for the Balaga Formation, actually is consists of submetamorphic and semi-metamorphic shell succession of huge thickness with intercalation of gravel and sub-gravel sandstone. So mainly rock here is shell, layer member. Layer member is shell, carpet member mainly phyllite. Also is also because of the influence by the metamorphic process. So it's phyllite, meta and plagos mainly occupied in the Murum area, which is quite sandy. The bawang member, I'm not really familiar. So if you see this layer member, all the shell is a sheet, including this phyllite also, because this is part of the tensional and the compressional stress along the rock due to the tectonic setting. So it is very loose, very fragile. Okay. Actually, all this material, like I said, shell, argillite, siltstone, and mudstone, actually, we consider as argillaceous rock, which is very rapidly disintegrate into clay when exposed. You see, this excavation, when you excavate this material, weighted material, at first it's actually it's rock. After that, after you leave it a few months, this will become clay because of the disintegration. It's very fast here, especially in the layer member. So it's very sensitive. The moment you expose, you better do some slope protection or some very proper drainage system in this one. It will some contribute to the erosion. The shell is give a lot of problem to the construction, especially on the slope. Okay, the Liang Formation, actually, this is the youngest geology formation in Sarawak. Liang Formation succession. Actually, it's not even rock, actually. It's a succession of sands, clay, gravel beds with some lignite, a very young apparent and poor consolidation. So for this kind of material, it's a very sandy, and then it's the moment you expose can eroded away very fast. Like you said, this two photo actually from Google. You just can go there and then see what happening in this Liang Formation. This is between Selangor and Mukah area. So on the disturbance at the bottom of the slope, it can happen. Retrogressive collapse will happen because of sandy nature of the geology. And then this one also you notice that also the vegetation also very hard to grow in this kind of sandy material. Okay, and then the conclusion for the Cebu zone, deep pit, I think similar to the Kuching site, deep pit with high mystic content, ground treatment, R&R, extensive temporary work. You have to consider temporary work. Otherwise, you will end up with a very massive cost implication. So I have to this one. So for the Blaga formation, like I said, the argillaceous material, seabed erosion, this is important. It can disintegrate very fast to clay when exposed, and also vegetation does not grow well at this weighted material. But actually, for the foundation, I think should be no problem lah. And then liang formation, very loose sand, actually not stable as a compaction material. We did this before at one of project. We cannot achieve maximum dry density targeted MDD. So because of the loose nature. Okay, for the foundation, definitely we need some temporary work so because to prevent the erosion of the material. And also construction risk on slope is a severe gully erosion. Soil piping may happen in this kind of material. Vegetation also does not grow well in the sandy. Okay, we go to Bintulu area. Bintulu area mostly covered by the underlined by the Nyalau Formation, which is intermediate Akos and Mudstone. Akos is actually sandstone that very high content of the feldspar, more than 35%. So it's actually it's a combination between uh, sand and clay. So this two combination is not really good for the construction. Okay, and also I will share a bit on the hard pan in this Nyala formation for the foundation. So stub shell also similar to the layar member of this one. So they have a thick shell and also the material also isoclinal folding. Okay, Nyala formation consists of thick sequence of shallow water marine and a prolific sediment rock. Predominantly sandstone and shell. So actually the sandstone actually is aqueous. And then the aqueous itself is very easily detached because of the clay content inside the rock, this material. So actually the sand particle can easily roll down because of this clay. So it's very slippery when it's infiltration into this kind of material. And also mudstone source that very easily source the mud crack and also can disintegrate fast to clay when exposed. So this is a pen. And usually there's a lot of the evidence, even though the bedding dipping very gentle, but still show sliding between these two type of material, siltstone or aqueous and mudstone. Siltstone and mudstone or sandstone or aqueous and mudstone. So these two combination is always contribute to the failure. This case actually because of the top layer siltstone or aqueous actually is a very high permeability. When the water infiltrate into mudstone, which is impermeable, so the water cannot penetrate this and then become a sliding plan because it's very slippery. That is the case. Okay, I want to share one of the sliding plan happened in the Nyalau Formation. Okay, this sliding actually when you do the kinematic analysis, it shows a phaseologically toppling. It's not a sliding, but actually on site is this is affected by the sliding first because of the water infiltrate into this layer, you know. Even though the thin is a very thin layer of mudstone, so the thing still can slide down because of the slippery, because the analysis itself did not consider water and also cohesion of the material. So this is why this failure happened because of the water affected by the water. So you can see here, this is like I said earlier, this area is a very high permeability. The water seep in, cannot penetrate this material, mudstone. After that, for the longer period, all the block and top here will be slide down because of this condition. And also on the other hand, of course also I mean the grass, what turfing here in this case turfing does not grow very well in this slope, in this coarse material. Okay, this is another evidence of the, because it is this how to remove. Okay, this is a soil piping. Okay, I want to say one case. Okay, if you see this, the first information that we have a pothole here. Okay, and then we have the filtration crack. At first, we thought that this is a failure, but because we don't know how this become a pothole, it might be something happened there. So we put up some borehole here. So from this borehole, we find out that the sub starting from a certain depth, I think 1.5 meter or something like that. So that is we found is a void down there. And then there's a massive water loss during drilling. So during the drilling, we find out the water coming up from the toe of the slope here. And then we drill up to certain level until we reach aqueous layer. And then we found that that is massive water loss is from 3.5 meter to 9 meter. So when we do the sum of this one soil profile, and then we found out that the thing happened because of the soil piping happened in the hard sandy sill. This hard sandy sill actually is the hard course, is a weathered hard course. So maybe this mudstone extend down here. Okay, that's why it's coming up from here, because this line is, he cannot penetrate this, even though it's a very thin layer. Because we know this information because we found on the other side of the slope. So this is geological information. So because of this sandy nature, so this soil piping happen in this material. Okay, this one is about the hard pan. Hard pan is actually how to this one. Okay, sedimentary rock, hardened deposit of calcium carbonate. Actually, it's a limestone, but it's happen to be in between the mudstone. If you see an exposed cut slope, it's a one layer, 1 meter, 1 to 1.5 meter is a hard pan here. So in the slope, maybe not much problem that we can
Paham, baik.
but for the foundation, this will be a very big problem for the foundation, especially on the pile foundation. Okay, and then we found there's a few groove feature because the water cannot, there's a accumulated here, and then all the mudstone the accumulated here become clay. So there's a lot of a very thick layer of clay. So that is another problem with the foundation. But for slope, maybe not much issue here lah. Okay, that is on the up end. Okay, for the stub shell actually is a bit further up toward the Miri side, not in the Bintulu area, mostly on the hilly area, the Baram area. So the stub shell is composed predominantly of shell with subordinate sandstone. It consists of shell interbedded with some sandstone, so a bit of sandstone. But actually is also a few lenses of calcareous sandstone and limestone have been recorded, but so far I never experienced in this two type of this material. And then it show a very steep bedding, isoclinal folding because of the isoclinal folding. So similar to layer member of a Blagger formation, there's also this shell also easily disintegrate into clay. So the failure also can happen in this very steep shell bedding, very steep. This is from geology map, one of the geology Brunei area shows this isoclinal folding here. Okay, as this one I conclude for the Bintulu site. Actually, from Nyalau formation, what is a probable geological condition is interbedded coarse and mudstone or siltstone and mudstone, and also hard pan calcrete layer. And then that also possible for the foundation pothole because of the coarse type. Later I I explain a bit more about the Maligan formation, how is a pothole can form in this kind of material. So pothole due to the opening up of joint plane wash away and the foundation problem in hard pan. So this is on the foundation. For the slope, severe erosion, possible for sliding along bedding plane and or toppling failure, soil piping, massive water loss or sediment loss. Also grass also does not grow well on the weathered coast and stone. And then the second one is a stub shell. That is a probably geological condition, very steep bedding due to the isoclinal folded, thick shell, slippery when wet, disintegrate fast to clay when exposed, similar to layer member. Foundation, I think not much issue here because of this kind of type of mineral. But for the slope, there's a lot of risk here. Sliding along bedding plane, severe erosion, also vegetation cannot grow well there. Okay, we move to the geology of Miri, Limbang, Lawas. You see the Miri site, and probable geological for Miri is not also pit area, especially at the Baram, Kuala Baram. Miri site is the Miri formation source that bedding plane daylight or dipping toward west of sea, similar to the Setubong site. So that's a possible for the sliding toward sea. This is what happened in the Canada Hill there. So that is another unprobable geological condition here. But I'm not going to discuss about that. Okay, just for information. Unprobable geological condition at Limbang area, we have a blight formation. This yellow is a blight. Actually, blight knows with his when it exposed, it can become clay that contain pyrites that can affect on your foundation. And then Liang formation also very low sand, very low sand here, especially in the Limbang airport, that kind of site. So this site, and also they have a stub shell, a bit thick shell, but not much here. But the mainly of the rural area, like the hilly area, is a stub shell. So it's similar to like I explained before. So it's similar condition. And then the Lawas site. Okay, the Lawas site is a probable condition is a Maligan. I will make it detailed because we have a lot of experience in this Maligan formation, which is collovium, arkos, and also intermediate arkos and mudstone. Similar, almost similar to Nyalau. Okay, stub shell, also Temurung formation, a very thick shell. Later I show some model. This one is a Maligan, the yellow one. This is stub shell. Okay, that is on the town area, and also closer to the town, there's also a pit. So the construction risk for the pit also similar. Okay, the Maligan formation, actually, I created this model for the Maligan Formation, especially for the disturbed area. Maligan Formation is a predominantly arenaceous formation, composed mainly of massive sandstone with subordinate concentration shell and thin layer of quartzitic sandstone. And then the bedding is gently bedding dipping. But at our recent mapping, Barrio also shows as a very steep bedding, up to 80 to 90 degree. But this formation is not folded. It's just not much folded lah. Just almost similar, but like the Lawas area mostly is a gently bedding, but the Barrio side is a very deep, deep, very deep, steep bedding. Okay, for the improbable geological condition for this type, based on this model, is you can see there's a possible for rockfall. If you do some kinematic, it shows toppling failure. There's a lot of boulder down there. Okay, after that is a very thick collovium can happen because of this nature. Okay, and also interbedded across a stone. Similar case, wetting front due to the water seepage. Actually, to explain this, actually the permeable shell of mudstone become very slippery when wet. Okay, continuous exposure to water seepage regardless of the geological dipping outside or daylight or toward the inside slope may result in wet front, and also in the long run can subsequently to slope failure. So this is mentioned, and then show the photo there. There's a evidence of failure between these two type of rock. Even though the bedding dipping toward inside slope, so it's not daylight, but still can happen. And then from this photo also you can see the water seepage, wet front. This is what I call wet front. This material, the water infiltrate in this very high permeability. This one, impermeable mudstone here, and then this here already happened, the landslide between this zone. So that is the trigger for this failure. Okay, and also from the ARCOS here, there's a possible for the detachment or opening up of the detective plane along for the flat ground, even though in flat ground, but when the water infiltrate, the material wash away, wash down, so everything is washed down. So in the long run, that pothole is become bigger and bigger. So there's a lot of risk that can happen if this happen in any of the project. Okay, some photos shows that the condition along the Maligan Formation. You can see a lot of boulders along river. So these boulders also can affect on the debris flow, especially if there is a very steep valley. But this one flat maybe not much issue because of the boulder is quite large. And the loose block or toppling because of the easily detached. There's a lot of toppling, and also you can see there's a lot of waterfall within this Maligan Formation is staggered because of the toppling. So that is also another evidence, and a very thick collovium below at the bottom of the hill. So for this construction of the slope also, you may end up large border, you find large border on slope. So the decision whether you want to remove heck using the machinery or breaker, or leave it in situ with some protection, or you put shotcrete or a cement screed, whatsoever. Because if this can easily break, I think you better break. But if this shows the sporadal weathering, it may roll down in a very big hole there. That is another geotechnical constraint in this kind of material. So loose block also here you can see because easily detect. Okay, that is another. This is some of the photo shows that what happened in the Maligan Formation. Okay, Arcos. The characteristic of Arcos in this formation actually easily detach and erode away. So the moment you expose the material, it's already break, and then you can see the separation here. So it's I don't know, maybe because of the young geology condition, or maybe because of the excavator that make things worse. Okay, and then also potential for fallen boulders, rockfall, because of this potential for this easily separate. Okay, sliding and toppling. And also soil piping, you can see soil piping also can happen in this material, and opening up of a joint plan, or pothole along on the ground. So you can see there's a few pothole here. The one that I mentioned just now, this is on the flat ground. So you see this soil piping shows that the black color because of the water is staining because of water. So that is a lot. So this uh, seems like the stream underground. So your slope will fail because of this water. And then another slope photo shows here is very easily detached. This is the Akos. So another thing that important here is the formation of a collovium, with a rockfall, debris, and boulders at the slope toe. This is will be a very major problem to the construction. Okay, this is the model based on this information that I discussed earlier on the Meligan Formation. Collovium, actually the material that started at the bottom of the hill because of the uh, failure and also the toppling issue here. You know, the bedding dipping, even though toward inside slope, but cut perpendicular by the joint plan, and then you can see there's a lot of the angular border down there, and also a lot of failure this material. So in this material, creeping happen because the movement keep move, especially when the infiltration or water seepage infiltrate into this kind of material. Very high permeability movement. There's a lot of this one failure. A few series of the failure. So this thing keep move, never stop. Imagine if you build something there, rod whatsoever, and then this is will keep moving. You know, when moving you repair. Now after that, moving again. So this affect a lot of the structure here. So that is mostly happen in the Lawas area or this side. This is some example tension crack that we can found along this collovium. A matter of time, it can become bigger and bigger. Collovium slope, you can see there is a lot of the border here, not sorted properly. That is the one of the character of the collovium, and also quite large border. This is another one from that area. And then what make things worse here actually is the bottom part of the Meligan Formation is a shell, a stub shell or tumurong. So when, like I said earlier, if the infiltration into this material, so that is stub shell, the shell or mudstone of this formation becomes slippery, so make things worse. So it's another potential that make everything keep move, you know, especially when you disturb at the toe of the slope. So that is a very risk. Actually, the collovium at Lawas area can up to the 10 meter actually, very big because of the hilly area part. Okay, if you look at this geology map, you see on the area that I highlighted in green here, actually this is the collovium. Just indicative only. You can see from this photo also, you can see this along the SLR1. You can see this black color is a stub shell or tumurong formation. On top is a collovium. Along this road, actually, there's a lot of failure happen along the road. Keep moving. And then this is very slippery. And also from this Google image, actually you can see collovium cover here because of, and then you notice that there's some landslide scarp up there. So that is the one that produced. So actually in the geology map, the Meligan Formation here, but in this column is a stop shell, you know. So when you do some geological assessment, you have to consider this column as well, not only because of the presence of the stop shell, but you have to consider this because column, the moment you disturb, you will keep moving. Any disturbance, in fact, it's naturally still can fail because this material is very loose and very high permeability, very high porosity. So this keep moving, creeping will happen over time here. Especially, I don't know, maybe because this rod also is like this. I don't know, but there's some evidence the movement takes place. So the new rod alignment here, SLR1 may have to take this into the consideration. So that is the something in the colloquium. Okay, some photos shows the colloquium area. So there's a lot of boulders along the new road there. And also you can see this is, I think this is a stop shell here or Temurong formation. And also see the seepage between this, you know, similar case to the, like I mentioned previously. There's a lot of boulder, some is big. Sometimes you don't know whether you need to remove or not, or just leave it there. What happened, Metal Tan? How about the drainage? Where you want to discharge in all this mission? You may need a subsoil drain and all this. That is should take into your consideration. Slope protection, like the drainage, everything. Okay. Conclusion for this area, actually, Maligan Formation. Actually, there's a lot of information, but Maligan Formation mainly in the developed area so far. There's a lot of another rock formation like Kelalan Formation, which is also shell and some other rock formation that we need further study also. So the unprobable geological condition here because of the toppling failure are caused, the present are caused colloquium at foot of the hill, very thick colloquium, soil piping. We have evidence on that also, opening up of the joint pan or pothole on the ground. So, and the water seepage at boundary between Arkos and Maston, wet front that I just mentioned. This one also can contribute to a large failure. So the construction risk on the foundation, especially on the large boulders, so far maybe not a really concern because not much development in that area, but actually is will because of the new SLR rod, maybe there's a lot of the development will take place in future. Especially the pothole. That's why the pothole you need to determine concrete loss. You have to consider your concrete loss. So if you look at this model, so actually you have to understand the spacing of your joint plane, the major joint, because there's separation. So if possible for for concrete foundation, you have to avoid this pothole. That is the risk for the foundation. For the slope also, there's a lot severe gully erosion because of the sandy nature of the aquos, water seepage, landslide due to the wet front, rockfall toppling, of course. Naturally also as it will fail, not even with disturb. Debris flow, boulders along rivers, undermining of concrete drain, if you can see here, all this colloquium or arkos is the same thing. So the water not go into your drain because of the water undermining this drain. And also there's a lot of large boulder here. This is a measure about, I'm not mistaken, it's about 4 meters here. This hole, we just excavate this down. And then there's already a separation between the that joint plane. So that is another risk. Have to consider so that there's no concrete loss here happen. Okay, need proper interceptor drain. Any construction you have to do is an interceptor drain on top because you want to discharge water away from your slope. Okay, you need to divert any of the possible encroachment of the water into your slope. Okay, that is this one. And also subsoil drain or maybe horizontal drain. You may need that also. Maybe you need to put a very long horizontal drain in your design. You have to consider the worst case scenario. Or because of this porosity, maybe happen on the slope also rapid drawdown of the water. That's why you need this kind of subsoil drain in your design. And vegetation, I don't know, not sure whether can grow well in the collobium, but definitely of course it's not is the case lah. Okay, I think that's all what I want to share. So as a conclusion, now we know that I think the worst case that we can see here from the Maligan Formation because of the younger geology formation and a lot of the development there. Not only that, maybe if there's a lot of the excavation or construction in the younger geology, it might end up in this kind of situation. Younger geological elements are typically breakable and quickly separable when exposed, and adjacent rocks crumble, disintegrate, or disintegrate easily into soft clay. At first, when you do some excavation, the material shows a very, highly weighted rock. After that, become clay a few months later. So this is something that you have to consider. And also for the construction risk, a temporary and permanent protection work essential when constructing slope foundation, especially on the concrete, hard pan, road building with poor geological condition. And also geotechnical consent construction risk on the slope foundation have a lot of to consider this consider because it can make your project a very massive loss if you not tackle this properly, especially for the designer. And then I want to conclude the unfavorable geological condition in this geological formation is sheared brecciated material, which is from the Tuang Formation I explained earlier, limestone in the Perawan Formation, concrete in the Nyala Formation, and also this also applies on the Bauk Formation, any related to the limestone formation. And the third one is argillaceous rock disintegrate easily into clays, open special. We have to understand this. The moment you disturb, you have to protect immediately before you proceed with the other construction. So that's why that is the information that have to be carried out simultaneously with your construction. You cannot go further down unless you have to protect or put some of your drainage or interceptor drain first before you proceed, especially on the slope. And the foundation, I think no issue lah. And then interbedded sandstone, earthquartz, and mudstone. Of course, this one because of the impermeable and also hyperpermeability or layer, so the water can make the bottom part is a very slippery, and then so that the top part is a slide down. Also, earthquartz, there's a lot of issue with earthquartz. Actually, it's a sandstone, but it's totally different characteristic from sandstone because of the uh, clay content inside there. If you go to the up the hill on the Malinga Formation, you can see a lot of like you walking on the sandy beaches because of the white color, but you just found only sandstone because clay is already washed down by the water. So that is how easily erode away this kind of material. And also collobium. Collobium is very thick a certain area because of the potential failure characteristic of the earthquake itself. Okay, and for geological condition, provide geotechnical constraint to the construction of slope and foundation cost. And also, as we now we understand that the different geological formation give the different geological characteristic and also different solution. So every geology formation, we have a lot of formation from Jabatan Mineral, You can get some from them, you can buy, but you have to know how to interpret the information. Because characteristic of the different rock formation is different in term engineering because of whether younger or older rock formation. But this information may not reflect on the geology at Semenanjung because that area is a quite old geology and also mostly by the manganese granite introduced into the material so that material become schist or phyllite, so which is more harder than sedimentary rock. I think just nice 1 hour, Mr. Tan.
Yeah, very
I
good
think that's
timing.
my presentation. Good job.
Very good timing. Yeah, good timing. Exactly 5 o'clock. And that's good. We have the full 30 minutes for Q&A lah. Yeah, very
Yes.
very interesting presentation.
Yeah.
Covers the whole of Sarawak, all the different rock formations
Yeah.
and problems. So before I open for question, maybe I should encourage James, if you can, write up your talk lah. Choose the highlight part. Maybe write out a paper on what you have presented lah. Maybe not the whole thing, just select the very interesting parts lah. So send it for publication in our bulletin so that other people can.
I will make because before this I did this presentation at earlier this year as a KL under IAEG or something like that, Asian. But that one is just a very brief, but I think I want to compile later on because all the information that I give today, I believe it's very hard to find in the any reference because this is, I mean, mainly on the engineering. So I will share this information.
Because it is a very comprehensive lah. Yeah, so it is good to publish it. Okay.
Thank you.
Now I open for Q&A. Who wants to start? I see a few familiar faces lah. Names, sorry, in the audience. Anybody want to start the Q&A session? Or do I have to call names again as usual? How about our fellow Sarawakian, SP Chen? Are you still there? SP Chen?
Yeah.
Okay.
Hi, Bun Kang. Nice to see you,
Yes.
Bun Kang.
Okay,
Thank you
yeah,
very much.
nice.
Thank you very much for organizing all these interesting, regular GSM talks. It is
Yeah, good.
very good for us
Yeah.
to refresh ourselves in our knowledge. But firstly, thank you, James, for a very good presentation. Really appreciate, you sharing this information with us. I like one of the statements you made, you said for those thick shell sequences that weather very quickly. So the moment you expose them, you should actually do the necessary works to protect them. So this is very good. But actually, in reality, from what I see, this rarely happens in the sense that they just expose the slope and leave it there and then wait for it to weather down and then erosion gets on, and then you have gullies form, and then also you have slope failure. So I think this is more common than the people making dedicated effort to protect it. So I think this is what I see actually in the general industry, construction industry. Do you agree or not?
Yes, I really agree. That's why I have to mention that when you start your excavation, you have to protect first before you proceed further. This is very important actually. A lot of time happen in the every construction because different contractor doing different things. So sometimes they're not, they cannot match each other. The one that they excavate the whole thing and then leave it like that. The toughing guy not coming in until everything is finished. So this is what happen in construction.
Is it because there is very little or no budget allocated for this type of work, because they think that this is not, so to speak, directly related to the project per se. This is something just in the peripheral, so they are not allocating the necessary budget for this type of work for the protection of the slope.
I don't think so because every designer they will put in all this information. Just that we have to make some note that this to be done before you proceed, something like that. So from top of the hill, you start there, you do some protection, drainage before you can do other things. I think this is mainly on also the supervision team also has a very takes important role here to make sure they're done accordingly. So you have to be quite strict in this situation. So if you really survive, I mean, you have to advise the contractor that what they should do because sometimes they are not really aware of the erosion siltation process, correct? Especially characteristic of the material. That's why you have to advise them. But one more thing that I want to highlight here, for the construction of the any slope or anything, you must put geologists on site. I think this is my advice to everybody. Geologists do some supervision works, especially on the slope area. I think that is my suggestion lah, so that everyone understand. Because the geologists must go to the ground to analyze whether there is a possible what is the geological constraint that can help a designer. Of course, when you do design, your design not completed yet until you finish the construction. So when you finish construction, after that your design completed. Your design can change during the construction, so you have to monitor. You send someone RE, so this RE also have to monitor properly. So this one also still real liability to the designer also. So that is my point lah.
Yeah, that is also another, sorry, Pung Kong. There's another
That's
point.
okay.
Just now, what we mentioned was the natural slope, the
Yeah.
failure of natural slope. But in addition, there is also a man-made, man-made situation whereby in order to win some flat area, they just flatten the area and bulldoze this material to the side and then just leave it there. So that is also another case of hazards waiting to happen. And most of the time, this is because they want to do it fast and cheap. This is what they normally.
Yes.
And almost always these slopes are not protected. That's why you cause so many of these slopes are having problems.
Yes,
So that is what we observed today.
yes. And also you did mention on the material that you just push down the slope, So in any contract or whatsoever, you have to allocate some dumping area, because selected as per this one. So the contractor can quote this price. Not they just bulldoze like that, but they have to send out the material, the unwanted material. If they not use that for the compaction, they can put dump at the selected area that approved by the designer. So this is another thing that should be considered. So the tender itself is also play important role.
Then, of course, the stability of the site for dumping also must be studied before
Yes,
they can dump
definitely.
them. Yeah.
That's why
Okay.
all the dumping area have to be agreed by the designer.
Okay. Thank you, James. Thank you, Wong Kong.
Okay, thank you.
Yeah, okay. Next question. Anybody?
Maybe all understand.
No, they always have to wait for me to call their names. Dr. Gani, you're still there?
So my lecturer.
Okay,
Okay.
Yeah,
thank
Dr.
you.
Gani, yeah.
Can
Yeah.
hear me or not? Can, huh?
Can,
Can,
yeah.
yeah,
Okay,
Dr.
thank you, Mr. Tan. Very interesting to see you again, James, after some time. I think the last time was Josie in Langkawi. Maybe I start with a comment because it's a long time that I was in Sarawak. But what you talk about, what you show us now, shales and mudstones will rapidly disintegrate into clay. That's
Yes.
something I've seen myself. So I don't want to say where I saw that, but I've seen something like that myself in Sarawak. And the other one, of course, also in Bintulu, we have this kind of thing. What I am actually missing in this presentation is some testing results, whether even a simple point load test or Schmidt-Hammer test that will actually give us some idea about the strength of the rock, because some of the sandstones actually were quite, I think that was in Bintulu, lah. They were quite strong, but the rest of it, like I said, and James has also said, you expose it to the atmosphere, it will just disintegrate. So there is actually, maybe I'm still, the academician is somewhere inside me, there's room for research now, why this material is so easily disintegrates and all that. But the next time or in the future, or if we have the opportunity, do some rock testing or soil testing or whatever is in between, and maybe some geophysics, because that will then give us some idea about what kind of strengths we are looking at. So I think other than that, the presentation is sort of relatively complete, and I will add my voice to what Mr. Tan has said. I think some of these things will be useful to compile and publish, because it is, although that also applies to me myself. I've got a lot of data somewhere, but I have not written it up. So it's interesting, but my own experience, which basically agrees with what you have presented here, is that in Sarawak, the geologists will maybe be critical, but the geology is actually quite straightforward and simple. But once the material is exposed, then all these things that you have shown happen. So what we actually have to come up with is some sort of cooking recipe, or whatever you want to call it, of the steps that should be taken. Let's say if you expose the material within a certain time frame, what should be done? Because I think it's possible to some extent, protect the site from this kind of erosion. I think that's more or less what I want to say. Thank you very much.
Okay, actually, what you mentioned pilot test, actually, we can do that also. Actually, they have a handheld. You just can bring to the site also for pilot test. But for this, you see this slide. Actually, last time we did this one, my project with the Geotechnical Geotechnic previously. We did some XRD analysis for this mudstone layer, because we want to check with the characteristic of the clay mineral here inside the mudstone. So also because we have to inform engineer that what is the characteristic of every rock or soil, so that we need to prove to them. This is another thing that I agree with Dr. Gani lah. So not only this, maybe we also can do some other testing also. Dr. Gani, I think I agree with you in this sense.
Yeah, there's a test for shales in soft rock, which is the slake durability test. Because your soft rock shale mudstone is a tendency for slaking, you see. So that's how they break down easily. So there's one test in the lab, slake durability test.
Actually, slake durability is you can do very simple way. Actually, you can put some shell or mudstone inside. You put up a soak into the water for 24 hours, and then the next day. Actually, this is I did for the Pan Borneo before lah. I soak this shell or mudstone. After 24 hours, I will observe whether it's a disintegrate or some breakable. If breakable, we will instruct the site memo to be shotcrete because of the potential erosion. So it's a very simple test. I also agree with you, Mr. Tan.
That is actually called slake jar.
Yes.
So how was it after 24 hours? Had it disintegrated, or was it still solid? I think it's probably all nothing left.
You leave it for 24 hours, you can see some, they have standard actually. You can see how.
Yeah, that's like that. There's one of my students did it for some sedimentary rocks in Perak.
But I did for the one type of Klalan formation did not show any changes. So Kelalan formation actually is quite good also.
Okay.
Something like that. So any of the argillaceous rock, we can do some slate durability test lah. It's a very simple one. There's a few reference. I think Dr. Gani has done it before, isn't it? Slate durability.
Yeah, slate durability I've done a lot, and
Yes.
also the slate jar. In fact, there is like I mentioned, my student supervise.
Yes.
You look for. We publish the paper in GSM, so we try to find this. Although that is here in Semenanjung, I try to look for the boundary between what we want to call soil and rock. We use slate durability and we use the jar test also, lah, but more on the weathered material, lah, because is the weathered material is, especially in sedimentary rocks, is not easy to sort of quantify like in granites now. So
Yes.
that one is like I said, mentioned earlier, like if you have some of those values, of course it'll also be very useful for the engineers who are going to be designing and doing the construction, because then they know how the material will behave.
Yes. Okay.
But now somebody else must talk. I have talked. I talk too much. Thank you very much.
Okay. So thanks, Dr. Gani.
Okay, next question. There's a question in the chat lah. Can the guy, can you speak up? Ask the question directly. No need to use the chat. I saw one question in chat. And the guy who wrote the question, can you ask directly to the speaker? Keeping quiet.
Hi, I'm Yi here from
Yeah.
Geotechnical.
Okay.
With regards to your very early statement on the limestone area, where you have mentioned, Mr. James had mentioned that to treat the infill, we have to clean it up. How to clean it up?
You have to pump out. I also not really this one, but before you do grouting, you need to pump out, especially I feel that because that mostly the gravel or sand, a lot
I
of
think
mixture there.
quite impossible to pump up lah. I mean, a small cavity, no issue lah. You can flush it out lah. But if it's a big one and there is water loss and fractures, I thought we can clean the whole lah. Normally, we use cement or mortar to compact grout the thing with high pressure lah.
So you mean you enhance the material with the cement mortar, is it?
Into the sand or clay will be pushed aside and compacted lah. Sand cement can easily permeate and then get it hard lah. That is my opinion and my curiosity how to clean the infill. Is it? If small one no issue, big one I doubt we can clean. Most of the time we cannot clean and we just compact grout it.
So you enhance the material lah, because with the
Yes, that's the only way, because
actually
if a 2 meter cube size of cavity, how to flush out that thing or suck out if it's deep, impossible lah. Most of the time we don't do that lah. I think the
you can check with
recommend that.
Jutrajasa did some of the how they pump this material with the Oxingli. They did this for the Kuching West management project actually.
Oh, if it's soft, where you can dissolve it with or mix a blend
very
dissolve
hard
the clay,
to
then you can
pump out.
probably flush it out lah. Palm, you say unless it's a very big hole, then borehole, then yes, you can put in big pumps to go and pump it out. If it's a small hole, when normally cavity treatment, we don't drill so big hole lah. So bigger pumps cannot go down to pump out the slush or whatever. And then first thing is that normally infill there is either not most of the time it's fine sand or the decomposed type of material but it's quite dense not easy to flush out unless there's a very big cavity, a very big fractures where the soft clay slime silt can go into, and over time it create a deposit of thick clay lah. Clay probably you can still flush out, but not easy to clean up lah.
Yeah,
The
no,
only
no,
way
it's
is to compact it
maybe
lah.
what your method maybe can works because we have to make sure this hole will be intact. But the
Yeah.
problem now, you don't know how big is this hole because it can bend, can be
Yeah,
extended
that's what
very
because
fast actually.
uncertainty. So that's what you
Uncertainty.
need very high pressure to compact it lah. Most of the time, big cavities we use mortar, granular mortar to grout it lah. Smaller one we use cement grout.
Okay. Next
Okay.
question.
I think this is a question.
That's it.
Sorry, I think this question from Lobis here. He said, I also the igneous intrusion, Padawan and so on. Actually, igneous intrusion, I just try to leave it this the Tuang formation because I don't know whether it's a part of the accretionary prism ataupun because of the intrusion. But actually, this to me the intrusion is actually make the rock stronger. Actually, if shell is become phyllite because in Kuching area there's a lot of the intrusion, so you can find a lot of phyllite or schist. It's a very hard, so it's better than shell. So it's no issue actually. It's not effect. And also it enhance the strength of the rope. That what I can see. Oh, Mr. Tan, will you agree with me on that?
Okay, we move to the next question.
Okay.
Yeah. Anybody? Okay, I have a quick question. Your limestone in Kuching, do you get sinkhole problems like our KL limestone? Sinkhole in
no,
the
because
Kuching area.
Kuching area. So far I never heard about that because actually you can see this map. I show you this map, the Kuching side. Actually, all the Padawan formation at this Masja started from Masja until State Archive. There's a State Archive there, and also but this area is not 100% developed yet. The
No,
building
I mean you mentioned in Kuching the bedrock, you have limestone bedrock, right? But there's no sinkhole.
So far we did not observe.
Okay.
Because actually this model is from the Masja area, so I forgot to put the legend, but actually it's not big lah. This hole.
Okay. Because in the Bao area, lots of sinkholes. Bao, the old
About limestone. This one is Padawan.
the Bao limestone. Also Padawan. Is that one also Padawan, right?
About what is about limestone?
Yeah, and lots of sinkholes there.
Yeah. Padawan, definitely. This
yeah. Okay.
quite a lot.
Right. We still have 7 minutes. Anybody want to ask questions? Ask directly if you can. Ask directly.
Can ask later also can. No.
I thought the Bao sinkholes were formed because of dewatering the gold mine. Remember the Blue Lake?
That's right.
That was the cause of it.
Yeah. That's the belief lah. Actually, there was a study on that, but the reports were made confidential lah. Chop sulit, so no one can read about it. So it was a sensitive issue lah. So yeah. But definitely lah, pumping of the Blue Lake lah, the big ex-mining pit that became the Blue Lake. The thing was practically pumped dry lah, so that they can go back and dig some more gold, you see. So that triggered all the sinkholes. That's a general conclusion lah. Anyway, it's a sensitive issue. Okay, but in Kuching area, there's no sinkhole.
I never heard recorded lah actually.
Okay. All right. Next question. Yeah, Fateh, ask some questions. Fateh.
familiar with Kuching area.
Sarawak, question on Sarawak.
But the only thing I know was the Bao limestone.
Wow, limestone. Okay. Which is a bit sensitive, cannot talk too much.
Yeah.
Yeah.
Okay, my one more question. Your shale, you have some black shale, right? Black shale, black color. Do they have pyrite in it? And do they cause problem? Acidic?
Actually, pyrite problem,
in the black shale,
I not sure, but we never experienced, because if there is the foundation on your pyrite, there's a lot of the foundation problem. But so
yeah.
far, I just saw some erosion. Let's say you see this blind formation.
Yeah.
There it is actually. Even though
Yeah,
you cut down
on the cut slope lah, black shale on cut slope.
You do the platform on the cut.
Yeah.
Like I said, when this exposed, it will become clay, even though it's a cut, So the reaction of the pyrite is make some settlement happen. Actually, there's some area. I noticed there's a few area that this happen actually.
Okay.
So this is another thing that we have to consider in our foundation design, especially how to test the contents of the pyrite clay mineral. You need to do some testing there lah. So that is my
I want
suggestion.
to test the soil, the what they call the pore fluid lah, the fluid, the water in the soil.
Okay.
Just do the chemical test. pH is very simple.
Okay.
pH will be acidic lah, 2 or 3.
Okay.
Yeah. Okay.
Okay. Very interesting, because we might expect some problem with this kind of construction.
Yeah. Because the pH is low, acidic, so your vegetation cannot grow. That's the other problem. Cannot grow grass.
Definitely.
Like
This one definitely because of the, especially on the stub shell.
Yeah.
The grass cannot grow.
Right. Okay. Any more questions? We still have 4 minutes. Plenty of time for Q&A lah.
Stay tuned. Time, stay tuned.
Plenty of time. 3 minutes.
Hello?
Yes.
Can you hear
Okay.
me?
Yeah. Okay. Ask directly. Ask. Fauzia, eh?
Yeah.
Okay.
Okay. Actually, I asked from the chat box earlier because I have to babysit.
Yes. Yeah.
So, Mr. James, from the Lawas Road towards Lawas Highland, we can see a cut slope exposed the boulders. And these boulders is along the dry river. So, during the wet season, there is a potential for the boulders to move towards the new road. So what is your suggestion to protect this boulder from affect the new road in Lawas Highland?
You mean the road is still in situ, or you already moved it further away?
I'm sorry, come again?
Is it that border is still in situ? Or...
Yeah, in situ. The border is along the road.
Yeah, actually, because if you remove this border, it's very dangerous, because you might end up a very big hole on the your slope. But I would suggest that you leave it there. Try to break using your breaker if possible, because but this will be quite costly. But you can put some cement screed surrounding, but to enhance with the BRC. Or shotcrete, the expensive way is the shotcrete. So you enhance to the border, so that the border will not roll down in future. But the view is not tidak cantik lah, because there's a
indeed,
like this photo.
Only that chainage, I believe they have a lot of boulders along the road.
Yes.
I remember along Sukang, is it?
Yes, I've been there. So similar to this slope. Actually, this is so at Lawas, but a different area. For this case, a lot of time we just leave it there, but we put a cement screed to hold the boulder, so that not roll down in future. Because if you not do a proper drainage, the water might undermine this boulder, so that it can roll down. So interceptor drain you have to put up there also. The cheapest way is you just cement scrape or cement mortar surrounding the boulder.
All right. Thank
Actually,
you,
it's
Mr.
very
James.
hard to break, is it? Using breaker?
Yeah, that is possible because this is from my experience while using the road. But I'm not working with any contractor at the area.
Okay, okay, okay. But
Mr.
actually,
James,
it's better to leave it there lah, because
yeah, I believe so.
yeah, mm,
Mr.
that's
James,
my
there is
opinion.
yeah, thank you. And there is another question from another chatter. He asked, there is a igneous intrusion within Padawan Formation at Bawa area
Mm,
and also Kayan Sandstone at Kubah National Park.
mm.
In your opinion, will this intrusion affect the slope stability for slope around Kuching area towards Bau?
No, because actually, Bau area is a very limited. This intrusion during museum time. Actually, mostly it's a record tengah light lah. I don't think it's really affect much on the stability because actually the rock surrounding is even more strength because of the metamorphism. That is my opinion lah. I don't think so because so far we never experienced any failure related to this two formation. And also the intrusion also very limited, scattered all over the place. I think no issue
Okay,
on that.
good to know. Thank you, Mr. James.
Yes, yes.
Okay, I think our time is up. So
Mm.
we thank the speaker, and I also
Okay,
thank
thank you,
the
everyone.
audience, for coming to the talk lah. Just
Yes.
one last thing before we go is turn on your camera. We take a group photo for our newsletter. Can you all turn on your camera? Dr.
Okay.
Gani, turn on your camera. Gani, huh?